Hello everybody, Marie here with the McWane Science Center. Welcome to another SciSparks. Today, we're going to be exploring how thunderstorms form. Stay tuned. We've all experienced thunderstorms before. Rain, wind, lightning, thunder, sometimes hail, and maybe even a tornado. But what happens to cause a thunderstorm to occur in the first place? That cause has to do with air temperature and density. Density is a measure of how much matter there is in a certain amount of volume. When things float in water, they are less dense than water. Or rather, they contain less matter per the same amount of volume as water. When things sink in water, they are more dense than water. Or rather, they contain more matter per the same amount of volume as water. Water itself has different densities depending on the temperature or salt content of the water. Today, we're going to be using this temperature-dependent property of water as a proxy for air involved in the formation of thunderstorms, since air also has different densities depending on temperature. In front of me, I have containers of clear lukewarm water, red warm water, and blue cold water. The red warm water is less dense than the blue cold water because its molecules are moving around very quickly and taking up more space. In other words, there's less matter per the same amount of volume in the red water compared to the cold water, whose molecules are moving very slowly and taking up less space. So what does all this mean? Have you ever heard the idea that warm air rises? Well, that's because of the lower density of warm air. Let me demonstrate. I'm going to pour this red warm water into one side of my clear lukewarm water and my blue cold water into the other side. Now, keeping in mind that warm air rises because of its lower density, what do you think will happen to the cold air? Let's find out. Now observe as I pour the cold and warm water into the lukewarm water. What are you noticing? That's right, the blue cold water is sinking underneath the red warm water. In regards to water, this is how deep ocean currents function. But in regards to air, this is how thunderstorms form. Warm, moist air rises. And when it gets high enough up in the atmosphere, it cools down. Water vapor condenses into liquid water droplets, clouds form, and the now cooled air sinks back down where it warms back up, rises again, and continues the cycle. This rising and falling of air is called a convection cell. The greater the amount of moisture and air involved, the more likely it is for a thunderstorm to form. The greater the rotation of these different temperatures of air, the more likely it is for a thunderstorm to produce a tornado. I hope you enjoyed this episode of SciSparks. Be sure to subscribe to McWane Science Center's YouTube channel for new content. See you next time, and thanks for watching.